So this is lesson 9.3. C is in CAT, College Trigonometry, Exponential and Logarithmic Functions. We're on example 7, and we're going to start doing some algebraic kind of solving here. And they start out giving us this here. Now, one of the things that I want to tell you, and I know you may end up forgetting it, but it's good to write it down. When you're looking for the exponent here, you must change this exponential form into a logarithmic form. Doesn't matter if you change it to a natural logarithm or a common logarithm, you're not going to be able to solve it unless you do that. So when the variable is in the exponent, what we end up doing is we take the log of both sides. Okay? You could have also written this as ln of 7 to the x power equals ln of 12. Either way, you converted them to logarithmic format. Okay, now we keep going. We put our x in front of our log. We do the same thing if we were using natural logarithms. Okay? Now, we're trying to solve for x, so we're going to divide both sides by the log of 7. Okay, those cancel, and we get, let's put it down here, log of 12 over the log of 7. Same thing over here, x equals ln of 12 over ln of 7. Alright, then you just take your calculator and you find the log of 12 and divide that by the log of 7, and you get your answer. And again, you're going to get an approximate. You're not going to get exact. Dealing with logarithms, you don't very often get exact. Alright, so let's go to example number 8. Now example number 8, if you notice there, also has exponent of a variable in the exponent. So we are going to end up finding the logarithm of both sides. That's a point. Okay, so let's take the ln. All I did was stuck an ln on there. Doesn't do anything difficult there at all. Oops. Alright, now I can move my exponents to the front. Let's put that in parentheses. Okay. Now what do we do? Let's see here. How about if we distribute 2x ln 3 minus 1 ln of 3, and let's distribute this to x ln 0.4 plus 2 ln 0.4. Okay, so what I did is I multiplied that and that, okay, to get that big long equation there. And the reason that I did that is because eventually I'm going to get all the x's. I'm going to move that to the other side. Now I'm going to move this to the other side. Sorry, I mean normally, whoops, I would have done both of those in one fell swoop, but okay, so let's move stuff up. Alright, so let's combine what we can. Well, alright, so I've got an x here and an x here, so I'm going to factor an x out of there. Okay. And over here, I'm just going to leave it alone. I am going to take the 1 off of there. That doesn't need to be on there. Okay, and I've got that. Alrighty, so let's see. I'm trying to solve for x. So this is multiplied. So if I divide both sides by 2 ln of 3 minus ln of 0.4, this goes away. And my x then equals that. And that's what I was looking for, a way that I could write this as x equals something. Alright, so now let's look at what we've got here. Let's look at this. That actually is ln of 0.4 squared, right? Because I can move that there. And the same here. Okay, so 0.4 squared is ln 0.16 minus ln of 3 over ln of 9 minus ln of 0.4. Alright, we get to this point and I can actually use my calculator now. So I take ln of 0.16 minus whatever I get for ln of 3, subtract those, and then I divide, and I'm done. Okay? So that brings us to example number 9. Let's see if we can get rid of all this. Let's see how this just kind of goes on and on and on. Example 9. Alright, we have, oh my goodness, I can't even read that, e to the x squared. So we've got an exponent to an exponent equals 200. Alright, so again, my variable is in the exponent position, so I'm going to take the ln e of x squared equals ln, don't forget to do it to both sides, to that. Well, ln of e to any exponent equals the exponent. And how do I get rid of an x squared? I take the stinking square root of both sides. And remember, I get a plus or minus. So x equals plus or minus the square root of ln of 200. So then all you do is take the ln of 200, take the square root of it, and you get plus or minus, I'm just reading from the book here, 2.3018. Okay, so I get that for an answer. So my exponent right here is either 2.3018 squared or negative 2.3018 squared. Alright, so that is A. So let's look at B. Okay, e to the 2x plus 1 times e to the negative 4x equals 3e. Golly, you can do this in front of your mom and dad and they'll just go, oh my gosh, you are so smart. Alright, let's make that 4 look more like a 4 instead of a kindergarten 4. Alright, well they skip a bunch of steps in part B in the solution, and I will fill those in so you don't have to be so incredibly lost. But remember, when you multiply things with exponents, what do you do with them? You add them. So this would be e to the 2x plus 1 plus negative, oops, come on, negative 4, go on, there you go. Alright, so let's add those exponents. 2x minus 4x is negative 2x plus 1 equals 3. Whoops, is that e an exponent? No, that e is not an exponent. Okay, so that gives me that. That looks a little bit better. Okay, so let's see, what are we going to do here? Oh, let's divide both sides by e. Get rid of that. Alright, so when I got rid of that, let me put my 3 back there. What does it mean when you divide? We have e, just like up here, when you multiplied, you added. When you divide, you subtract. And that's a 1, so that would be minus 1. That's this one right there. So that gives me e to the negative 2x. Positive 1 minus 1 is 0, so that gives me that. Okay, so this is where I'm at right now. Alright, next step. Let's see here. Since we're looking for x, and it's in the exponent, let's go ahead and write this in logarithmic form. And remember what you do with exponents. Now I divide by ln through e, and those go away. Negative 2x equals ln of 3 over ln of e. Okay, so back a lesson or so, you found out that ln of e is 1. So let's move that back up there. So if ln of e is 1, then we get negative 2x equals ln of 3. Divide both sides by negative 2. Those go away. So we take ln of 3, divide it by negative 2, and we get our answer of negative 0.5493. Okay, jump to example 10 in the next video.